Alright, today I'll talk about the problem Beef McNuggets. So in this problem, we will find the largest number that cannot be constructed using a few of the numbers that we have. And so this can be done using brute force, but there's also another way that you can do using a few math tricks. So here's the code. Here I will set this Boolean array to keep track of all the numbers and see if that number of nuggets is impossible or not. And I set this here to only 1 million, although the maximum could be 2 billion, because here it's actually a really tricky question. The largest possible is actually just the largest number you can have multiplied by another largest number that you have, and then minus the sum of those two. And so the maximum number that we have is 256, and so we'll just do this, and the result is actually only 65,000. So this is why that you can also use brute force to solve this. You can just literally loop through all of the 65,000 numbers and check if they are possible. If you find one that's not possible, then you will just set the answer to that. Otherwise, if all of them are possible, then you will just print out 0. But here's another way you can do. So first, after reading in all the number of nuggets that we can have in one package, I will loop through all of them and find the ones that are a multiple of each other. So if they are a multiple of each other, for example, if xj is divisible by xi, then that means that any number that we form is using xj can be formed using xi. And so we can just remove xj because we don't need it anymore. We can just use our xi. And so this wouldn't do much though, I think, because we only have 10 at max, so this might come in handy if you have another larger size. And here we'll get the greatest common denominator of this whole number. So this is the x will be the available number of nuggets in each packaging, and here we'll check after we get all the greatest common denominators. We will check if that is equal to 1 or not. If it's not equal to 1, this means that all of them will always have a few gaps between them when you add them up, and you'll always be able to get a number that is not that cannot be formed using those few number of packagings. And we will just print out 0 because that means we can have an infinitely large number. The other case is when we have no possible numbers that can be formed. Then that will be the case when our smallest number of nuggets in a package is 1. This means that we can just give out an infinitely amount of packages, and we'll just have each of the numbers from 1 to 65,000. And so that will also be 0, meaning that we don't have any possible case. And otherwise, we will be able to find an actual largest number. So first, I will set all the impossibles, set this Boolean array out to 0, and that means that everything currently, we're just saying that everything is possible, but here we'll change it later on. And first, this will be our answer that we'll print out at the end. And first I will set it to x0 minus 1. This is the smallest number of nuggets in a package that we have, minus 1. We do minus 1 because this will be smaller than our smallest number of nuggets. And so we will not be able to form this number using our numbers that we received. So here, everything smaller than that will also not be possible using any numbers in x. So we will set all of those into impossible as well. And here, I set it all the way to 1, not 0, because 0 will still be possible since you just don't choose anything. And here, I will loop through all the way from this current impossible number all the way to 2 billion, but the actual case actually will only be 65,000. And here outside this, I'll keep track of a continuous amount of numbers that are all possible to make. And if that is equal to 256, this means that every number afterwards will just go in a loop, and all of those will also be able can also be made using our numbers. And so if this is already 256, we will stop this program because everything else will be possible. And otherwise, we'll just check if this current I is impossible or possible. So we loop through all of the values that we have in X. This is the amount of numbers that we can package in one packaging. And so here we will make sure that this current J is smaller than our I. And we'll have to make sure that this current J is smaller than or equal to our I. And then we will check if I minus J is possible or impossible. So if I minus J is possible, this means that I can also be possible because we can just add J to our this current possible number, and then we'll be able to get I, and that will also make I possible. So we will set our current this F to 0 and stop this loop. And otherwise, this will just keep on going. So if at the end this I turns out to be possible, this F will just remain as 1 because we won't encounter any case like this. And so here we will check if this current I can be is impossible to construct or is it possible to construct. If it's impossible to construct, we will set our answer to I because this I goes from smallest to greatest. And we'll also set impossible I to 1, meaning that this is actually impossible to construct. And we will reset our continuous count of possible numbers because now we just encountered an impossible number, so the amount of continuous numbers that are possible will just become 0 again. Otherwise, this means that this current I is also possible to make, and we'll just increase our count by 1 for this continuous number. And so this will just keep on looping until we reach this case when the continuous number is equal to 250, and finally this will stop the program and we can print out the answer.